Good morning, students. We are discussing on railway and airport engineering. We have starting discussing about the railway engineering portion, wherein in the previous lecture we have started discussion about geometric design of the track. In that lecture we have discussed about one of the parameters that affect the geometric design, and that was grade and the grade compensation. And we have also done with one of the example of that. While in today's lecture we will move forward with one of the another parameter of the geometric design, that is speed and the superelevation. While starting with the first parameter, that is speed of trains on the curve. For that we have to understand the concept of equilibrium speed. What is equilibrium speed? Well, when the speed of a vehicle negotiating a curved track in a way that the resultant force of the centrifugal force and the weight of the vehicle, which is perpendicular to the plane of the top surface of the rail, and the vehicle which is not subjected to any unbalanced radial elevation, that is in a equilibrium condition. Okay, so at that particular state, the speed of the vehicle is considered as the equilibrium speed. Well, in a simple words, if we say the equilibrium speed is the speed at which the effect of the centrifugal force is completely balanced by the cant or the superelevation that we have provided. Clear? Now, what is the safe speed on the curves? For all kind of practical purpose, the safe speed, that means a speed which is safe from all the dangers of overturning and the derailment with a certain margin of the safety. While to negotiate with the curve, the speed of that vehicle depends upon few factors, and those are the gauge of the track, the radius of curve, the amount of superelevation or the cant that is being provided, the purpose or the absence of transition curves at the end of the circular curve, if the circular curve is being provided, and the distance at which the resultant of the weight of vehicle and the centrifugal force acts from the center of the track. So the distance, the presence and absence of the transition curve at the end of the circular curve, amount of superelevation, the radius of the curve, and the gauge of the track. So these are some of the factors which affect while negotiating the curves with a speed or the safe speed. Well, talking about the speed, there are some of the formula with respect to the broad gauge, meter gauge, and the narrow gauge. So for the broad gauge, to find out the safe speed, we have the formula as V is equals to 0.27 under root CA plus CD into R, where V is the maximum speed in kilometer per hour, CA, that is the actual cant provided in millimeter, CD is the cant deficiency which is permitted in millimeter, R is the radius in the meters. Okay, same way for the meter gauge, the value is 0.347 under root CA plus CD into R, and for the narrow gauge, V is equals to 3.65 under root R minus 6. So these are some of the formula to find out the safe speed on the curve if you know the radius of the curve. Well, the next let's discuss about the superelevation. Well, what is superelevation? When a train moves around a curve, it is subjected to a centrifugal force which is acting horizontally away from the center of the curve. Now, to interact this centrifugal force or the effect of centrifugal force, the level of outer rail is slightly raised, which is like slightly higher than the inner rail. Okay, this raising elevation, okay, of the outer rail above the inner rail at a horizontal curve, while this process or this provision of the rise of outer rail is known as the superelevation or cant. While talking about the objectives of the superelevation, which is to ensure a better distribution of load on both the rails, also to reduce the wear and tear of the rails, and also the rolling stocks, which is the wheel, also to neutralize the effect of lateral force and to provide the comfort to the passengers on that particular curved track. Okay, so these are some of the objectives of providing superelevation. While discussing for the equations or discussing about the formula that how we can find out the superelevation from the speed as well as the radius of the curve. Well, the formula that is E is equals to gv square upon gr, where v is meter per second. Well, in the metric system, if we need to find out the superelevation in millimeter, which is probably be found, okay, so that E is equals to gv square upon 127 r. Well, for this equation, the values of G, V and R should be in a specific unit. Well, where V should be in kilometer per hour, which is the speed, R is the radius of the curve, that should be in meter, and G is the gauge distances. While that gauge distances should be in millimeter. So for the broad gauge, that distance is 1676 millimeter. For the meter gauge, that should be 1000 millimeter, and for the narrow gauge, that distance should be 762 millimeter. Okay, there are some of the limitations for providing the superelevation. Well, the maximum value of superelevation generally adopted around many railways, such as 1/10 or 1/12 of the gauge of the track. Okay, so this is kind of a limit of providing the superelevation. Well, now if a train passes the particular curve with higher than the equilibrium speed, then what could be done? For that, what should be the provision? Or okay, so the next topic, that is the cant deficiency. Well, a cant deficiency probably occur when a train travels around a curve with the speed higher than the equilibrium speed. Well, this cant deficiency is the difference between the theoretical cant required for such a high speed and the actual cant which is provided. Well, the cant deficiency is limited due to some of the reasons. That is, the higher cant deficiency causes the greater discomfort to the passengers, and this cant deficiency leads to the greater unbalanced centrifugal force, which in turn lead to the requirement of stronger tracks and fastening to withstand the resultant lateral force. These are some of the reasons why cant deficiency is being limited. Well, now let's see one of the example which is based on the equilibrium cant as well as the maximum permissible speed, which also include this cant deficiency topic. So what it says? Well, what would be equilibrium cant on a meter gauge with having a 5 degree of curve for a speed of 40 km per hour? Well, what would be the maximum permissible speed after allowing the maximum cant deficiency? Well, first of all, let's see the given data. While here the degree is been given, degree of the curve. Well, from the degree of curve, we can able to find out the radius of that curve. For that, we have the formula d is equals to 1720 upon r. With that, the radius of the curve we will have, that is 344 meter. Well, the speed is been given, that is 40 kilometer per hour. And the track on which we have to find out this maximum permissible speed, that is of meter gauge, and for the meter gauge the value of g would be 1000 millimeter. Now here we are having the value of radius, speed and the gauge, so we can able to find out the equilibrium cant. And to find out the cant, we have the formula E is equals to gv square upon 127 r. We are having the value of g, v and r. So let's substitute these values in the formula, and the value of equilibrium cant that we got is 36.62 millimeter. Well, from the equilibrium cant, we can able to find out the theoretical cant that should be provided for this type of track. Clear? Here in the next term, we have been asked that to find out the maximum permissible speed. Now to find out that speed, we could have the value of g, we could have the value of r and value of superelevation, that is cant. Now here the cant that we provide, that should be the theoretical cant. Now to find out the theoretical cant, we have the formula, that is theoretical cant is equals to equilibrium cant plus the cant deficiency. For the meter gauge, the permissive maximum cant deficiency that is allowed is 51. Okay, so and equilibrium cant that we got, which is 36.62 millimeter. So the theoretical cant would be 36.62 plus 51, which is 87.62 millimeter. Then from that value of theoretical cant, we are able to find out the value of permissible speed. Well, here in the formula of E, which is gv square upon 127 r, let's subject the value of speed. Let's subject the speed, and the formula would be v square is equals to 127 into r into E upon g. We are having the value of r, which is 344 meter. Theoretical cant E that we have found out, that is 87.62 millimeter, and the gauge is meter gauge, that means the value of g would be 1000 millimeter. Substitute all this value in this equation or the formula, and we will get the value of v as 61.87 kilometer per hour. Okay, so this is our answer. The first question was what would be the equilibrium cant. Okay, so that answer is 36.62 millimeter. And the second question was what would be the maximum permissible speed with respect to the maximum cant deficiency, and that speed is 61.87 kilometer per hour. Okay, so this is how you can also find out the maximum permissible speed. So for that, here we have one of the example for the practice, which is on a broad gauge with the 3 degree of curve, you have to calculate the equilibrium cant for a speed of 70 km per hour, allowing the maximum cant deficiency. What would be the maximum permissible speed on the track? So students, find out the maximum permissible speed and let me know in the comment section what answer you got. Thank you so much students for your kind attention. I will see you in the next lecture. I hope you understand this topic properly. We'll see you with another topic that is regarding to the geometric design of the track. Thank you.